Soils are an essential key ingredient to life that lives right underneath our feet. They support everything from the food we eat to the air we breathe. Not all the soil under our feet is the same, though. Soils can have different characteristics depending on where they are in the world, influenced by climate, topography, human activity, and more. The first stop on our tour of soils is the Great Cliff Lamuse series, located in the agricultural fields about 35 miles west of Bozeman. This soil profile consists of fine loam over sand and is of the aquatic moisture regime. The Great Cliff Lamuse series is found in the Madison River Valley, where the river flows north through the basin, surrounded by flat farmland and great cliffs. Agricultural land use in this area is limited to corn and other basic crop cultivation, with the occasional cattle operation. Much of the land in this area is state-owned and used for agriculture, wildlife habitat, and recreational use. Since westward expansion, this area has served as farmland, and today it is being developed into housing. Initially, this profile was created with a deposit of loess material. Over time, the river eroded the soil, leaving today's topography. Alluvium and loess additions create the early soil. Weathering, anaerobic respiration, and human manipulation has produced the soil profile we observe today. The top soil horizon in this profile, known as the A horizon, clearly shows evidence of plowing. Therefore, this horizon is defined as AP. The second horizon observed in this profile is designated BG, as it is rich in secondary carbonates. Loess material covers the original parent material, giving the lowest horizon of this soil a 2C classification. Next, we visit Muskego, Wisconsin, where the Mundelein series is found. Muskego is a town in southeast Wisconsin just outside of Milwaukee. This soil profile consists of fine, silty mixed, and superactive material. This soil is an aqueous soil moisture regime. Prior to human development, Muskego was a flat, marshy location near sea level that continues to have significant groundwater. Urban and agricultural uses provide habitat for smaller creatures such as frogs and fish. Much of its historical agriculture uses are now being replaced by the expansion of neighborhoods and homes. Millions of years ago, ancient glaciers carved through Wisconsin soil, altering its landscape and soil condition. After the settlement of the Americas, this land had a long and rich history of agriculture use for over 100 years, until in 2015 when it was turned into a neighborhood. The Mundelein begins with a dark AP horizon, indicating plowing for agricultural use. It then splits into BT1 and BT2, meaning the clay has two separate layers, a more weathered, older version on the bottom and a newer version on the top. Then it splits into a BC horizon, indicating that the B horizon is slowly becoming a part of the parent material at Horizon C. Lastly, there is a 2C horizon showing that this soil has two different parent materials, which may have come from the glacial till or blow dirt. The last stop on our tour of soils is Holt County, Nebraska, where the Labori series is located. This soil profile is composed of sandy over loamy mixed material. This soil is in the ustic moisture regime. The Labori series is found under the Hay Meadows of Holt County, Nebraska, a productive, open grassland perched on the edge of Nebraska's sandhills, where dune tops soften into low, flat meadows, and groundwater feeds the grasses for haying, livestock, and wildlife. It's a working landscape, alive with blades of grass, the scent of cut hay, the quiet open space, and the subtle contours of one of Nebraska's great prairie systems. Many low-lying areas between dunes hold a high water table and are known as sub-irrigated hay meadows. Labori soils formed in Aeolian sands derived mainly from the Ogallala Formation and reworked during the late glacial drought periods. After the dune activity slowed and vegetation stabilized the surface, soil formation began. The Labori soil profile begins with a well-developed A horizon, which is dark brown to nearly black in color. Its texture ranges from sandy loam to loamy sand and contains a relatively high amount of organic material derived from dense, fibrous grass root systems. Beneath the surface lies the BW horizon, a weakly developed subsurface layer that shows subtle changes in both color and structure compared to the A horizon above it. Below this is the sea horizon, consisting of light-colored parent material sand. This layer shows little evidence of weathering or soil development and closely resembles the original Aeolian sediments from which the soil has formed. Soils are more than just dirt. They are the foundation of life, shaping ecosystems, agriculture, and even urban development. Through our examination of the Labori, Mundelein, and Grey Cliff Lamuse soils, we see how location, climate, human activity, and natural processes create unique soil profiles with distinct characters. From the productive hay meadows of Nebraska to the urbanized marshlands of Wisconsin and the river valley farms of Montana, each soil tells us a story of its environment and history. Understanding these soils helps us appreciate their vital role in supporting both natural and human landscapes and highlights the importance of managing them sustainably for the future.